This is Math Studies Lesson 3.1. In this lesson, we're going to introduce probability. So hopefully each of the things that we discuss in this lesson are probability concepts that you're familiar with already, and we're just sort of reviewing them before we get into some newer concepts in this chapter. So probability is the study, the mathematical study of chance. And chance, maybe another word for that would be the likelihood of an event. So I could say, how likely are you to have a coin land heads up when you were to flip it? Or how likely are you to win the lottery? Or what's the chance that you're going to get the flu this year? Those are all probability. So, experimental probability is when you actually conduct an experiment or try something several times. And if you want to report on experimental probability, you give the number of times you observed a specific outcome divided by the number of trials you ran. So I'm going to talk about coin flips for both of my top examples here. If I'm flipping a coin, and let's say I'm going to just keep flipping that coin maybe 10 times, and I record how many flips of heads and how many flips of tails I got, that's experimental probability because I'm actually doing an experiment. And let's say I flip that coin 10 times, that's 10 trials, and let's say I got 3 heads out of my 10 flips, my experimental probability of heads would be 3 out of 10. Theoretical probability, on the other hand, is the number of ways you could get an event out of the number of total possibilities or outcomes. And so sticking with the coin, there's only 2 possibilities when you flip a coin. You can get heads or you can get tails. So there's only one way to get heads, so the theoretical probability of heads will be 1 out of 2. Sample space is all the outcomes or all the possibilities of a situation. So the coin example had 2 possibilities, 2 outcomes, heads or tails. So on our theoretical probabilities, the denominator, the bottom number, is always however many items there are in the sample space. And then a complement is something not happening. And by that, I mean the complement of heads is tails. Because if you get heads, you get heads. If you don't get heads, you get tails. So it's kind of like the opposite, but yeah, something not happening. So we use a little slash line thingy, like an apostrophe almost, to represent complement. So the complement of heads would be tails. Okay, so a couple of examples. Sample space, again, is all the possibilities. So the sample space of rolling a die. You can roll a 1, a 2, a 3, a 4, a 5, or a 6. There are 6 outcomes in my rolling a die sample space. Okay, tossing 2 coins. So if I toss 2 coins, 1 coin can land on heads, the other coin can also land on heads. 1 coin can land on heads and the other coin can land on tails. And this seems like the same outcome, but it's technically different. The first coin landing on tails and the second coin landing on heads. And then finally both coins landing on tails. My brackets look funny today. But that is the sample space of tossing 2 coins. So the third example says drawing 2 marbles from a bag containing red, green, and yellow marbles. So it doesn't specify, but I'm going to assume this means there's 1 red marble, 1 green marble, and 1 yellow marble in this bag. So I can get a red and a green, a red and a yellow. I can get a green and a red, a green and a yellow. I can get a yellow and a red, a yellow, and a green. If that is the case. It doesn't specify, So if there were multiple red, green, and yellow marbles, I would have to add red, red, green, green, and yellow, yellow to my possibilities. So 6 or 9, depending on how you read the question. That's my bad. It's a pretty poorly worded question if there's more than one possibility. Okay, letter B. Sam flipped a coin several times and recorded her results in the table at right. Calculate the experimental probability of flipping a head. So this is just like what I was talking about earlier. Experimentally means we look at the total outcomes in the situation. There's 84 possible trials, and 36 of the trials resulted in a head. The theoretical probabilities just says look at the coin. How many possibilities are there when you flip a coin? And only one of those possibilities is heads. Finally, identify the complement, then calculate the probability. So first we have drawing a red marble from a box containing 5 red marbles and 8 blue marbles. So 5 red, 8 blue, 13 altogether. The probability of red would be 5 out of 13. The complement to red would be blue, because not getting a red means you got a blue. So the probability of the complement of red is the same as the probability of blue, which in this case would be 8 out of 13. Letter B, rolling a 1 or 2 on a die. So the probability of rolling a 1 or a 2, that's 2 sides out of the 6-sided die. So not 1 or 2. I think that's not grammatically correct. Come on. Come on. Come on. Okay. Is 3, 4, 5, or 6. So the probability of 3, 4, 5, 6 is 4 out of 6. Now you should notice that an event and its complement always add up to one whole. So if I add 5/13 and 8/13, that's a whole. If I add 2/6 and 4/6, that's a whole. So a probability event and the probability of its complement will always add up to one whole. Okay, that is it for the notes. Good luck on the exercises, and please let me know if you have questions.